Okay, now we talk about blockchain, what is it, etc. What is blockchain? A blockchain is a distributed database that is shared among the nodes of a computer network. As a database, blockchain stores information electronically in digital format. Blockchains are best known for their critical role in cryptocurrency systems such as Bitcoin for maintaining a secure and decentralized record of transactions. The innovation with the blockchain is that it guarantees the fidelity and security of a record of data and generates trust without the need for a trust third party. It's very interesting, really. One key difference between a typical database and a blockchain is how the data is structured. A blockchain collects information together in groups known as blocks. That whole set of information blocks have certain storage capacities and when filled are closed and linked to the previously filed block, forming a chain of data known as a blockchain. All new information that follows that freshly added block is completed into a newly formed block that will then also be added to the chain once filled. A database usually structures its data into tables, whereas blockchain, like its name implies, structures its data into chunks, blocks, that are strung together. This data structure inherently makes an irreversible timeline of data when implemented in a decentralized nature. When a block is filled, it is set stone and becomes a part of this timeline. Each block in the chain is given an exact timestamp when it is added to the chain. Now I talk you about key takeaways. It's very important things in this video. First is blockchain is a type of shared database that differs from a typical database in the way that it stores information. Blockchains store data in blocks that are then linked together via cryptography. Second is as new data comes in, it is entered into a fresh block. Once the block is filled with data, it is chained onto the previous block, which makes the data chained together in chronological order. Third is very important, one of the important things in this paragraph. Now I tell you. Different types of information can be stored on a blockchain, but the most common use so far has been as a ledger from transactions. Next. In Bitcoin's case, blockchain is used in a decentralized way so that no single person or group has control, rather all users collectively retain control. And the last is decentralized blockchains are immutable, which means that the data entered is irreversible. Bitcoin, it means that transactions are permanently recorded and viewable to anyone. And next question is, how does a blockchain work? Really, how it's work? Now I tell you about this. The goal of blockchain is to allow digital information to be recorded and distributed, but not edited. In this way, a blockchain is a foundation for immutable ledgers or records or transactions that cannot be altered, deleted, or destroyed. This is why blockchains are also known as distributed ledger technology, or else it's DLT. First proposed as a research project in 1991, the blockchain concept predated its first widespread application in use, Bitcoin in 2009. In this year, since the use of blockchain has exploded via the creation of various cryptocurrencies, decentralized finance or DeFi application, non-fungible tokens, NFTs, and smart contracts. Okay. Next is blockchain and decentralization. Imagine that the company owns a server farm with 10,000 computers used to mounting a database holding all of these clients' account information. This company owns a warehouse building that contains all of these computers under one roof and has full control of each of these computers and all the information contained within them. This, however, provides a single point of failure. What happens if the electricity at that location goes out? Interesting, yeah? What if its internet connection is severed? What if it burns to the ground? What if a bad actor erases everything with a single keystroke? In any case, the data is lost or corrupted. What the blockchain does is to allow the data held in the database to be spread out among several network nodes at various locations. This not only creates redundancy but also maintains the fidelity of the data stored therein. If somebody tries to alter a record at one instance of the database, the other nodes would not be altered and thus would prevent bad actor from doing so. If one user trumps with Bitcoin's record of transactions, all other nodes would cross-reference each other and easily pinpoint the node with incurrent information. This system helps to establish an exact and transparent order of events. This way, no single node within the network can alter information held within it. Because of this, the information and history, such as of transactions or of cryptocurrency, are irreversible. Such a record could be a list of transactions, such as with cryptocurrency, but it's also possible for a blockchain to hold a variety of other information like legal contracts, state identification, or a company's product inventory. Very important things I tell you. To validate new entries or records to a block, a majority of the decentralized networks computing power would need to agree to it. To prevent bad actors from validating bad transactions or double spends, blockchains are secured by a consensus mechanisms such as proof of work (POV) or proof of stake (POC). These mechanisms allow for agreement even when no single node is in charge. It's all for today. Thank you for your attention. Bye bye.